So for our experiment number 1, we will be experimenting digital output using LED and the PIC microcontroller. So for this experiment, we will be using the MPLAB XIDE program. So now we will be creating a new project. So microchip embedded standalone project. For this experiment, we will be using a PIC 16F18875. Then next, a XC8 compiler. Garcia GEXP. So set as new project, finish. Let's go to tools, embedded, then MPLAB configurator v4, open. Now we will just have to save this. Save. We have 3 peripherals. Interrupt module, pin module, system module. For this experiment, we will be using the RA4 import A output. So let's click this. After clicking, this should look green, then the input is color orange. So once that's done, let's go to pin module. The WPU should be untick and analog. Let's rename this LED. Then system module. Set the oscillator select to HFIN POSC. Then the high frequency internal clock to 4 MHz. Clock divider 4. Then low voltage programming folder should be enabled. So after that, we will generate the code here. Click generate. So once the generation is complete, we will go to project, then source file. Source file should have a main C file. For the main C file, we will create a code wherein the LED will light up per 250 milliseconds. Delay MS 250. LED. The name of the toggle. Build. Click build. So we will see the build is successful. After that, we will connect our microchip PIC3 to MPLAB IP. So I have here the microchip PIC3. Then we will connect this to our PC or laptop through a USB cable. I will also show you the pin diagram of the PIC3. You will see that there are 3 LED indicator. First one is the power. So if the power is green, meaning the power is supplied to the PIC3 via the USB port. Then when the active indicator is color blue, it is now connected to the PC using the USB port and the communication link is active. Then the status will light up green if it's ready to start, then orange it is busy with the function in progress or programming. When it is red, an error has occurred. We have the pin 1 indicator here, the triangle. So let's connect a connecting wire, MCLR or VPP here. Then the VDD target on the second pin. On the VSS or ground, third pin. For the ICSP data, we'll connect it on the 4th slot. ICSP clock, PGC, will connect it on the 5th slot. So once all the connections in the PIC3 are placed, we will now connect it on our programmable microchip. So here we have a PIC 16F18875. So I will also show you its pin configuration. Now we will connect the MCLR on the first pin of the IC. VDD, we will connect it on the 11th slot of the IC. VSS on the 12th slot. Data on the 40th slot, then for the clock on the 39th slot. Now, let's go back to MPLAB IPE. Here you can see the PC has recognized our PIC3. Let's try to connect it. Okay. So as you can see, the target device was not found. To solve this error, we need to go to settings, then advanced mode. There is a log on to advanced mode. The password is microchip. In advanced mode, we will go to the power, then let's set the voltage level to 3125. Power target circuit from PIC3, and let's go back to operate. Enter our program in the microchip, browse our hex file, so browse Garcia G experiment number 1, then go to this default production, then here is the hex file that we made earlier ago. Open. Once the hex file is loaded successfully, let's click program. Okay. Yes. So once the programming is complete, it is now time to test our program microchip. For this experiment, we program the RA4 slot, which is in the 6th slot of the microchip. We'll connect a connecting wire there. Then let's place a resistor. So let's connect the LED, then the negative to the ground, negative terminal, and positive terminal. For this microchip, all VDD and all VSS pins must be connected at the circuit board level. Allowing one or more VSS or VDD pins to float may result in degraded electrical performance or non-functionality. So we need to connect all VDD and VSS pins. VDD 11 slot, there, VDD, 32 slot. The VSS on the ground here, so 12 slot, and 31st slot. Now let's test it. So as you can see, the LED turns on and off every 250 milliseconds. Now let's modify our program wherein the LED will light up for 2 seconds and turns off for 2 seconds. So let's go back to MPLAB XIDE. Now let's set this value to 2000, which is 2 seconds. Then build. So the loaded hex file has been modified externally. Would you like to reload the hex file? Yes. We'll now connect again our microchip. So for the microchip first slot, so for the VDD 11 slot, VSS 12 slot, then the data on the upright 40th slot, then for the control 39 slot. So now let's browse again our new hex file. There, open, then hex file loaded successfully, then program. Once the program is complete, let's test again our microchip. So now let's connect our negative terminal and positive terminal. So now as you can see, the LED turns on for 2 seconds and turns off for 2 seconds. 1001, 1002, 1001, 1002, 1001, 1002, 1001, 1002, 1001, 1002. So now with the modification of our program, we were able to power up the LED with a time delay of 2 seconds. So it turns on for 2 seconds and turns off for 2 seconds.